We continue review calculus 2. Replace the polar equation with an equivalent Cartesian equation. So pretty much we have the equation in terms of r and theta. We replace that and we write as x and y. Right. So the formula is over there. Let me write out again. X equal r cosine theta. Y equal to r sine theta. And r square is x square plus y square. And tangent of theta is y over x. Yeah, watch out for this. We have to check the quadrant. Anyway, so that means if we have r cosine, that would be x. If we have r sine, that would be y. And if we have r square, that would be x square plus y square. Right, that's pretty much all we have. Right, so from here, cosecant is 1 over sine. Or we have r equal to negative 9 sine theta. And we can write this over 1 and then cross multiply. So r sine theta equal to negative 9 and r sine theta is y. So have y equal to negative 9. Right, next. R equal to 1, 3 cosine theta minus 6 sine theta. Now, once again, if we write this over 1 and cross multiply, we have r times 3 cosine theta minus 6 sine theta. Cross multiply equal to 1. Now multiply it out. 3r cosine theta minus 6r sine theta equal to 1. And r cosine is x, r sine is y. So we have 3x minus 6y equal to 1. Right, next we have this r square. Very tempting to write r square equal x square plus y square. Right, but if we do that, then we still have to deal with theta. So let's take a step back and write double angle formula. Sine of 2 theta is 2 sine theta cosine theta. So I'll replace that in here. Sine theta is 2 sine cosine, that double angle. Right, we can divide by 2 on both sides. So we have r square sine theta cosine theta equal to 32. Now we have r square sine cosine. If we keep one r with sine, one r with cosine, so that the r square is 1 go with sine and 1 go with cosine. Of course we divide by 2, did we? And that is y, and that is x. Yeah, so we have the equation. If we want to, we can say y equal to 16 divided by x. If we want to, we can write like that. It doesn't matter. This is good enough. Right. Right. Next we have this. It is a little more complicated than you think. So again, well, that is a fraction, then cross multiply. So we have r times 2 plus 2 cosine theta equal to 5. Right, now multiply it out. 2r plus 2r cosine theta equal to 5. So it's not that bad. And r cosine here, of course, is going to be x. Right, so that's good. Now the only problem here is r. The way to write r in terms of x and y is r squared equal to x squared plus y squared. Of course, here we can put the square root here. It's done. But if we have r squared, then we will have x squared plus y squared. So what I do here is subtract 2x on both sides. So we have 2r equal to 5 minus 2x. And then we square both sides. That gives us 4r squared equal to 5 minus 2x squared (25) minus 10x minus 10x plus 4x squared. And then the r squared here is x squared plus y squared. And then 25 minus 20x plus 4x squared. Right, and multiply it out. 4x squared plus 4y squared equal to 25 minus 20x plus 4x squared. So 4y squared equal to 25 minus 20x. Yeah. So again, for this problem, if we have r cosine, that would be x. If we have r sine, that would be y. If we have r squared, that would be x squared plus y squared. So we use all of that in here. Right. Oh, timestamp. Now find the slope of the polar curve given by this equation. Right, so this slope is dy over dx. Now we will have y is a function of theta, and x is a function of theta. Right. And then because r is y is r sine theta, and x is r cosine theta, the usual. Right, so we write out x equal to r cosine theta, give us 5 cosine 3 theta, and then cosine theta. Y is equal to r sine theta. R is 5 cosine 3 theta. and then sine theta. So we'll take derivative with respect to x, derivative of x with respect to theta. Right, product rule. Let this be u and v. So u prime v, derivative of this is negative. Derivative of cosine is negative sine, and then the derivative of 3 theta is 3. So we have 3 and 5, so that's 15. Now I'm just going to say 5 sine 3 theta, and then times derivative of 3 theta, which is 3. So that is u prime times v, and then plus uv prime 5 cosine 3 theta. Derivative of cosine is negative sine. Right, so when we clear this out, we have negative 15 sine 3 theta cosine theta plus, actually, minus 5 cosine 3 theta sine theta. Next, write dy over d theta. Right, once again, product rule. uv, so u prime v, u prime v plus u v prime. Alright, so that gives us negative 15 sine 3 theta sine theta plus 5 cosine square, cosine 3 theta cosine theta. Right, and now we're back to the derivative. Dy over d theta, dy over dx equal to dy over d theta over dx over d theta. Right, now just substitute everything here. Just be mindful that dy over d theta over dx over d theta. So this one, negative 15 sine of 3 theta sine of theta plus 5 cosine of 3 theta cosine theta over this negative 15 sine 3 theta cosine theta minus 5 cosine 3 theta sine theta. And we will evaluate at theta equal to pi over 3. Right, so I'm going to put pi over 3 in theta. So negative 15 sine. If we put pi over 3 in here, 3 and 3 cancel out, we just have pi. And then sine pi over 3. And then plus 5 cosine of pi. And cosine here of pi over 3. Over negative 15 sine of pi cosine of pi over 3 minus 5 cosine of pi, sine of pi over 3. Right, sine of pi, that's sine of 180 degrees, that's 0. So this will go to 0. Once again, sine of pi, 0. And cosine of pi is -1. So we have 5, -1. Cosine pi over 3, that is 1/2. And then we have -5, -1. And sine of pi over 3 is square root of 3 over 2. Cancel everything. -1 and -1 cancel out. 5 and 5 cancel out. We have 1/2. Over negative square root of 3 over 2. 1/2. Multiply reciprocal. So we have -1 over square root of 3. Right, so that's what we have. Right, next we go to the integral. Set up the integral to evaluate the area of the regions. Right, first r equal to 3 plus 2 sine theta. So I'm going to graph this heat mode in the polar mode. In radiant mode. Okay, that's good. And then we just enter 3 plus 2 sine of theta. And make sure the window from 0 to 2 pi. And I will graph 100 points. So from 0 to 2 pi, I divide by 100. So it graph 100 points. Alright. So it's like that. I'll just draw the sketch here. Let's see. 1, 2, 3, 4, 5, 6. Well, it's way up there. Kind of like that. Right. What we see is that this one is asymmetric on the line pi over 2. Theta equal pi over 2 on the y-axis. So because of that, if we want to evaluate, we can go from negative pi over 2 here and go to pi over 2 over there. Now if we do that, let's change the limit from negative pi over 2 to pi over 2. And you see we only have the right half width, which is good. So when we set the limit, just graph it on the calculator, make sure this is the part that we want. Right, and then the formula for the areas on that side. Right, so now let me write that formula. Alpha to beta, in this case negative pi over 2 to pi over 2, 1/2 f theta square minus g of theta square d theta. Right. Now we'll calculate the area on the right half and multiply by 2. So the area will be 2 times the integral from negative pi over 2 to pi over 2. Yeah, so 2 times a half. And then the area on the outside, the area, the function on the outside, the function inside. If we look from the center, looking outward, we only see the function on the outside. We don't see any function in the inside. Yeah, so as you see, only from the center to the graph itself. So f is going to be 3 plus 2 sine theta square. Of course, what I miss is the 1/2. 1/2 over 3 plus 2 sine square, and g, we don't have that. So let me rewrite this as 2 negative pi over 2 pi over 2 1/2, and then the 3 plus 2 sine theta square d theta. Right. On the test, if I only ask you to set up the integral, that's where we stop. But here, there's some space left. Let's just evaluate this. Bring down the 1/2. 2 times 1/2 is 1. So pretty much just negative pi over 2 to pi over 2 of 3 plus 2 sine theta square. Now, when we multiply this out, uh, 3 plus 2 sine theta and 3 plus 2 sine theta Three times 3 is 9. 3 times 2, that's 6 sine theta and 6 sine theta plus 4 sine square. And that's 12. Sine theta, and the sine square, that's the double angle formula. Minus, the angle will be double. And the power reduced by 2. So that is the power reducing. 4 and 2 cancel out. So bottom line is this. We have 9 plus 12 sine theta Four and 2 cancel out. There is still a 2. 2 times 1 is 2. So plus 2 minus 2 cosine 2 theta d theta. Right. Now the integral. 9 plus 2, that's 11. Plus 12 sine theta minus 2 cosine 2 theta. Right, integral of 11 is 11 theta. Integral of sine is negative cosine. And integral cosine is sine. But then we have to divide by 2 because this is integral. Going from negative pi over 2 to pi over 2. Right, substituting, we have 11 pi over 2 11 times pi over 2 minus 12 cosine theta is pi over 2, and 2 and 2 cancel out. Sine of 2 theta and theta is pi over 2, so 2 and 2 cancel, so minus sine of pi. Subtract. Now we're going to substitute a negative pi over 2. 11 pi over 2 minus 12 cosine of negative pi over 2 minus sine of negative pi. Because if you put negative pi over 2 in here, 2 and 2 cancel out. Right. So cosine of 90 degrees, cosine pi over 2, that is 0. Sine of pi, that is 0. So that is 0. That also 0. So I have 11 pi over 2 plus 11 pi over 2. And that, of course, is 11 pi. Right. So that's what we have for that problem. Right. So when we graph it, make sure if there's any symmetry, take advantage of that. And then find the outer function and the inner function. Right. So just that. Next, find the area inside the 3 leaf rows r equal to 4 cosine 3 theta. Right. 4 cosine 3 theta. Right. Change the window from 0 to 2 pi by default. Alright, so this is a 3 pedal like that, and look like the pedal 1, 2, 3, 4. So that is one. Of course, I could draw better than that, but so it look like that. So now first, let's set up the limit. Now the limit, we start from this function. The limit, if I have to draw one pedal, I start from the center and then go outside and then go back. Originally r equal to 0, then get back to r equal to 0. So we'll let this equal to 0 and find all the point. Right. Now cosine equal to first I will divide by 4 on both sides. So we have cosine 3 theta equal to 0. Now cosine equal to 0 is here or here, right? So over there is pi over 2 plus 2 k pi, or negative pi over 2 plus 2 k pi. Divide by 3 on both sides. So theta is equal to pi over 6 plus 2k divided by 3 pi, or theta equal to negative pi over 6 plus 2k over 3 pi. So now if we let k equal to 0, we have pi over 6 and negative pi over 6. So indeed, the limit, this is from pi over 6, negative pi over 6. So let's go from negative pi over 6 to pi over 6. Of course, if we let k equal to 1, we're going to have this and then we let k equal to 2, we will have this. So we have the different values for it to evaluate. Now, so that is the area of, that is the 3 petals. Now the petal itself is symmetric. So if we want to, we can only need to graph this part only. The area of half of the petal times 6 will be the area of the whole thing, right? So we know that from here it is theta is equal to pi is 0. So if we go from 0 to pi over 6, then we have half a petal. So I would go from 0 and pi over 6. Yeah, there's half a petal. So we say the area is equal 6 times the area of half a petal. Area of half a petal will go from 0 to pi over 6. And then we have 1/2 of f of theta square minus g of theta square d theta. 6 and 1/2 cancel out with 3. And the function square. Right. If we stand from the center and look out, we only see the edge is a Rolle's function, right? So we only have this function, there's nothing inside. Again, we did take care of the 6 and 1/2, that's 3. We just have the function square. The function square is 4 cosine 3 theta square. Right, so 3, 0 to pi over 6. That gives us 16 cosine square. And that is half angle formula. Cosine square 1 cosine of, power reducing, not half angle. Power reducing. The power will reduce and the angle will be double. Be 6 theta. Right. 16 and 2 cancel out. Right. Let's see, we have 3, 16, and the 2. The 3 and the 16 on the top, the 2 at the bottom. Right. 3 times 16, 48 divided by 2, 24. And integral of 1 plus cosine 6 theta is 1 plus sine of 6 theta over 6, 1 from 0 pi over 6. So that gives us 24. Substituting pi over 6. Pi over 6 substituting here, we just have sine of pi divided by 6. Subtract 24. Sorry. Integral of 1 is pi, right? I'm sorry. Integral of 1 is theta. And now we substitute pi over 6 into it. That's what we have. Sorry. Now, substitute 0 in for theta. 0 times 6 still 0. And so that is 0, that is 0. So the whole thing here is 0. Sine of pi also 0. So we have 24 times pi with 6. That gives us 4 pi. Right, so just that. Next, find the inside of one leaf of the 4 rows. 3 sine of 2 theta. Right. By default, it is from 0 to 2 pi. Right, so 4 rows like that. And the 3, so the rows will touch the circle radius 3. Close enough. Right, now, first let's find the limits. The limit for one parallel is start from 0 and go back and hit 0. Right, so we let this equal to 0. So we start from 0, get back to 0, divide by 3. So sine of 2 theta equal to 0. Now, sine of an angle equal to 0 will be here or here. So theta, 2 theta is equal to 0 plus 2k pi, or equal to pi plus 2k pi. Right, and divide by 2, so theta equal to k pi, or theta equal to pi over 2 plus k pi. Essentially, if we let k equal to 0, we have zero, and if we let k equal to 0, we have pi over 2. So from 0 to pi, that is one parallel. Now, of course, the parallel is symmetric. If we want to, we can cut that in half. But it doesn't matter. If we want the whole rows parallel, in this case, we want the one leaf. So one leaf, we can say the limit will go from 0 to pi over 2. We want one leaf. The area now we go from 0 to pi over 2. Or we can go from 0 to pi over 4, cut that in half, and then double it. But don't need to. Right, now. And then there's 1/2, don't forget that. Right. We have 1/2. I don't know why I did say pi over 2 and for somehow I write pi over 4. Sorry. If we want the whole parallel, 0 to pi over 2. If we want half of it, divide by 4. Right. Now, again, if we look from the inside, from the center, from the origin, from the pole, looking out, we only see the rows. So that will be the function. 3 sine square sine of 2 theta square, and then g will be 0. 0 to pi over 2, 1/2. That gives us 9. Sine of 2 theta is square, is sine square of 2 theta. That gives us 9 over 2. Sine square, once again, power reducing. 1 minus cosine of 2 theta over 2. D theta. Now take all the constant on the outside, 9.5 and 2. So we have 9 on the top, a 2 from at the bottom, and another 2 at the bottom. Right, now that 9 over 4, 1, integral of 1 is theta, integral of cosine is sine. Just slow down for a minute. What? The sine square have the 2 theta, we have to double the angle. Sine square, power reducing, the angle will be double. And integral of cosine 4 theta is sine of 4 theta divided by 4. Going from 0 and pi over 2. Right? Now we substitute pi over 2 in for theta. Pi over 2, substitute in 4 and 2 cancel out. We have sine of 2 pi over 4. And now we substitute in 0. Nine over 4, 0 minus sine of 0 divided by 4. Right, sine 0, that's 0, sine of 2 pi also 0, so that gone, everything now okay gone, and we have multiply this out, we have 9 pi over 8. Right. Find the area shared by the circle r equal to 2 and r equal to 4. Right, r equal to 2. That's the circle. And then the circle, we can just grab both of them. And then we go from 0 to 2 pi. Alright, let's see the graph. That's a circle, and then another circle. Right. Let's zoom in, but first let's make the scale look right. And then zoom in. Right, share by the two circles, so that actually that's what we have. Right, let me draw another circle. So we want the area that's shared by the two circles, meaning the overlapping of two circles. Right, so first we have to find the intersection. Oh, This will be complicated. We won't be able to find the area. We're just going to set up. First, we find the intersection. This intersection. Right, so I will write as follow. The intersection is where these two are equal, right? So I'm going to set r equal to 2 equal to 4 sine theta. And so we have 2 equal to 4 sine theta. So sine of theta is equal to 1/2. Right? So theta is equal to sine inverse of 1/2. Of course, as always, plus 2k pi. Or the sine of 1/2. Sine is the y value, is 1/2. So we might have this answer or the answer on the other side. Sine inverse of 1/2. If I do that, make sure that in the degree mode. At 30 degrees or pi over 6. So pi over 6 is over here. And then the other one is the supplement from it. I'll take pi minus pi over 6 plus 2k pi. So that's 5 pi over 6. Right, so that is the intersection. Right, that's the easier part. The complicated part is, notice that I will draw this out a lot bigger. See, we have 2 circles. I only need to draw the overlapping part. Right, so that is the overlapping part. And we have pi over 6 and 5 pi over 6. Now, the complicated thing is, this, what we want is the area of the whole thing here. But if we set up the integral, it will be like this. First, it will be that part of the sector. And then there are 2 parts, one of which is this. And then the other one. Right? So, this will have 3 parts. I will write out that area will have 3 parts. The first part is the sector. And then there are 2 of them. All we need to do is one of this segment. And 2 times 2 of those, because symmetry, the area will be the same. Of course, the sector here we can split in half and then multiply by 2, but let's just write that. So say the area will be equal to the area of the sector plus 2 times the area of whatever that shape is. But this shape would look like it go from 0 to pi over 6. So I go back and change the window only from 0 to pi over 6. Do you see anything? Nope. Let's zoom out. Oh, I know why. Should be in radian mode, sorry. Let's zoom in again. Right. So, actually, you see it does graph this part and then that part. So this is the correct part. If we only graph the circle on the top, that means we're not graphing the circle of radius 2. I mean, we're not graphing this. Then we only have that part. So that's correct. From 0 to pi over 6, we only have that part here, which is good. So set up the area will be, the area to sector will be from pi over 6 to 5 pi over 6. And then 1/2 and then plus 2 times the area of that part, which go from 0 to pi over 6. Forgetting the 1/2. When you get to calculus 3, we'll see why there's a 1/2. Right. Now, won't be able to evaluate this because we don't have a lot of space left. Right, now, for that sector from the center looking out, we only see the circle, right? We only see the circle in blue here, and the equation of that is 2. So we just have 1/2 2 square, and there's nothing inside. And then there 2 times the area of this shape, 0 to pi over 6. There's 1/2. Now, for that sector from the center looking out, we only see the graph of the circle on the top. And we square that. And there's nothing inside. I should simplify this. We have 1/2 times 2 square, 1/2 times 4 is just 2. And then 2 and 1/2 here cancel out. That's 16 sine square. Two and 1/2 cancel out, and 1/2 and 4 times 4 is 2. Right, so evaluate that will give us the area of that shape. We run out of space, and evaluate this will take some time. So we did quite a few of those, so we just set it up for that problem. Right. Next, we find the focus and the directrix of the parabola. So the parabola, the standard form is where the vertex is 0, 0 is either, if we have y square, it's going to be 4ax. Or if we have x squared, it will be 4ay. Bottom line is, this is in y. So first we're going to solve for k. Y squared equal to ax. And now we're matching for a must be 8. So a is 2. So what is 2? Well, the parabola here, y squared equal to ax. Y squared, so we'll open left or right. It is positive, so we open to the right. And then the 2 is the distance from the vertex to the focus. So we go 2 units here. That's where the focus at. And that will be 2 and 0. The directrix is on the opposite direction of the focus. So it will be -2. So we have the focus where the graph go around it is 2 and 0. And the directrix x equal to -2. Now this one, x squared -12y equal to 4ay. That is the form. So 4a is equal to -12. So a is equal to -3. Right, so this parabola x squared equal to -y squared. X squared is always positive, and there's a negative, so y must be negative. So it open down. X squared, so it open down. And the 3 is the distance from the vertex to the focus. So from here, we go 3 units. And that is negative x equal to 0, y equal to -3. That the focus, and the directrix is on the opposite direction. So y equal to 3. And directrix y equal to 3. Right. Right. Next we have find the standard form for the equation of ellipse center the origin and satisfy these conditions. Right. So in general, ellipse whether it's horizontal or vertical, it doesn't matter, but the form is going to be equal to, for the ellipse, center at the origin, x squared over something square plus y squared over something square. Now, if one of them equal to 0, if y equal to 0, multiply a squared. Here you have x squared equal to a. Okay, I'll just write it down. X squared over a squared plus y squared equal to b squared equal to 1. When x equal to 0, we have y squared equal to b squared. So y equal to plus or minus b. And at y equal to 0, we have x squared equal to a squared. So x equal to plus or minus a. Right. So the ellipse will be fit inside the box. Right. When x equal to 0, y is b and negative b. So b, negative b, and then a, -8 on the x-axis. So with that we have the little box. and the ellipse will fit inside this box. Right? So whatever the numbers at the bottom under x square, we go up and down square root of that, left and right, and whatever below the y square will go up and down. And there will be two foci where the function will go around it, and the distance from that will be c, and we have c square, in this case plus b square equal to a square. Bottom line is, from the center to the vertex, that is the farthest distance from the center, will stand by itself. The other two signs will be the other side of the Pythagorean theorem. Right, so this one is easy. Intercept plus or minus 5 and plus 0, x equal to 0, y plus or minus 6. So we'll make a box. And the ellipse will fit inside this box. Right. And the standard form, if the center is at the origin, so we have x squared over something square plus y square over something square equal to 1. Now, as we see, we go left and right 5 units and up and down 6 units. Below the x squared go left and right, below y squared go up and down. So we have x squared over 25 plus y squared over 36 equal to 1. Right. Next, we have the vertex, negative 6 and 6. And the foci, 5 and 5, 0. So the vertices and two foci. So what we have earlier, the distance from 0 to from the origin to the foci. The distance from the center to the foci is c. So we have c is 5. And from the center to the vertex, that is the biggest distance. Let that distance be a. This distance a is equal to 6. So a is equal to 6 and c is equal to 5. Now remember, we have a, b, c, 3 distance from the first point in this for the ellipse is the vertex, and then the other point, and then the foci. So in this case, we need to find b and a. The distance from the center to the vertex is always the greatest. So a square will stand by itself, because that is the biggest number. It will stand by itself. We don't know b, right? But we do know c is 5. So b square is equal to 36 minus 25. That is 11. So b is square root of 11, plus or minus, doesn't matter. Now, so that means we go up and down plus or minus square root of 11. Which is about 3.3 something. So we have the box up and down about 3.3 units. left and right 6 units, and the ellipse will fit inside this. Right, so the equation is x squared over something square plus y squared over something square equal to 1. And we go up and down square root of 11 unit, and we go left and right 6 unit. So that gives us x squared over 36 plus y squared over 11 equal to 1. Yeah, so it is important. For the ellipse, we know the box. The ellipse will fit inside a rectangular box like that. For the hyperbola centered origin, so there, for hyperbola, kind of the same thing, except instead of plus in the middle, we have the minus. So it could be y square over something square, x square over something square. So one of those. Now if we start with x square, this one is horizontal. If we start with y square, that is vertical. And when we still draw a box, this one like that, we go left and right A unit, up and down B unit, and then for the hyperbola we will draw the diagonal, and the hyperbola will fix into it. This one is the vertical. Right, and in the parabola there will be a focus, two foci, that where the graph go around it, and the distance from the center to a focus is C. In this case, C will be the biggest one. Right, now let's look at this. The vertex is 0 and 2, x equal to 0, y equal to 2. And then we don't know what happened on the other side. We know the foci here and there. The distance from the center to a focus is C. So we have C is equal to 3. And the distance from 0 to a vertex, from center to the vertex is, let's call that A. And for the hyperbola, from the center to the focus, that is the biggest distance. So it stands by itself. C square equal to A square plus B square. C 3 square A. So B square is 5. Or B is square root of 5. So we go, according to this, we'll go up and down 2 units. And then so we go left and right that much unit, like 2.25 something. And then we draw a box. For a parabola, we will draw, there will be 2 asymptotes. And the graph of the hyperbola will go around the focus and approach into the asymptotes. So that's what we have. Right, so this is vertical, by the way. So we start with y square over something square minus x square over something square. If it is vertical in this form, if it is horizontal, we start with x square. And then on the box, go up and down 2 units. So up and down will be below the y. Left and right will be below the x. So we have y squared over 4 minus x squared over 5 equal to 1. Right. Right, so that's all I want to go over. That's all I want to review for Calculus 2. Thank you for watching. Good luck on your exams.